Hey guys, welcome back to my channel. So today I'm going to show you guys how to balance chemical equations. I'm also going to show you the different reactions, and I'm also going to show you how to solve those. So the first question you need to ask yourself is, why do we need to balance chemical equations? Well, there's this very important law called the law of conservation of mass, and this law states all atoms on the reactant side must appear on the product side and in equal numbers. So just like in math, what you do on one side of the equation, you have to do on the other side. Next one is no new elements may appear. You can't add any elements that were in the original equation. Lastly, no elements may disappear. This means that you can't take any elements out of the chemical equation. I'm sorry if you're having trouble with balancing a certain equation, but you can't just think, oh, if I remove this element or add an element, then the problem will be balanced. No, it doesn't work like that. If you do that, then your answer will be wrong. So, yeah. So, next one is, so the reason why we need to balance chemical equations is because it needs to follow the law of conservation of mass. Okay. Now I'm going to show you the different types of reactions. The first one on the list, or the first one I'm going to show you, is called is synthesis reaction. And synthesis reaction is when two reactants are combined to make one product. And I'll show you with a diagram. So A, find another marker, plus B is made into, or changed into AB. So now I'm going to show you a practice problem. We got hydrogen and chlorine. We want to keep track of how many atoms we have on each side of the equation, so we're going to draw or make a little chart. Okay, so let's look at our subscripts. The equation says that we have 2 atoms of hydrogen and 2 atoms of chlorine. So let me just pull those out. So H, hydrogen, 2, and chlorine, I have, paper, stop moving, 2, okay, there. Okay, so now let's look at the other side. So on the other side, there is 1 atom of hydrogen, and there's 1 atom of chlorine. So let's just write that down too. So hydrogen 1, paper, oops, nope, that's not, okay, it's chlorine, I mean to put that, okay, chlorine, okay, so that's also 1, okay, so now that we have our information charted out, we can look at what we need to do to get this equation balanced. And to do that, we need to have a coefficient put in front of one of these reactants. Now, when balancing a chemical equation, you might think, oh, I can just change the subscripts, right? No, you can't. It doesn't work like that, because if you were to change the subscripts, you end up changing the whole chemical equation, making it a new substance, which can be dangerous. So instead, we change the subscript. Changing the subscript, we put a coefficient in front of the reactants to change it, like 2 here. Okay. So we're going to put a 2 here, and now we're going to distribute it. Nope. There we go. Okay, so 2 times 1 is 2, and 2 times 1 is also 2. Now this equation is balanced because we have the same atoms on both sides of the equation. And the paper is being difficult. There we go. Yeah, okay. Our next equation is called decomposition reaction. It's when a single compound is broken down into 2 or more elements or new compounds. So, like like below AB gets broken down to A plus B. So I'm going to show you an example now. So we're going to split this problem in half, or we're going to do a chart again. So H2, we have two atoms, we have one carbon, we have 3 oxygen, we have 2 hydrogen here, 1 oxygen here, 1 carbon, 2 oxygen. So let's find a pencil fast. Where are you, pencil? Okay, so let's pull what we have. So we have 2 hydrogens here, we have 2 hydrogens here. And we have 1 carbon, 3 oxygen, and 1 plus 2 equals 3. So this equation is balanced. Balanced. Okay. So okay. So our next reactant is single replacement. So if you think about it, single replacement is like a chemical square dance. The reactants switch places. So A will switch places with B, and it'll be changed to B plus AC. So let's do another practice problem. So we're going to do the same thing like we did before. Pull out the information again. So we have 1 potassium here, 2 hydrogen here, and 1 oxygen here. On the other side, we have 1 potassium atom, 1 oxygen atom, and 1 hydrogen atom. Right here we have 2. Okay, so let's see what we have, what we can pull out. So, looking at this, okay, and that's not open. Find another one that's open. Okay, there we go. So it says we have 2 hydrogen here and 2 hydrogen over here. Let me fix this because I just drew a line through it. 2, there we go. Okay, so we have 1 potassium here, 1 potassium over here. Oh, we also have another hydrogen. Okay, so that means we have to balance this. We have 1 here, 1 here. Okay, so what can we do to make these balance? Yeah, how do we make these balance? So if we have on one side 3 atoms of hydrogen, on the other we have 2. Let's balance the right side first, I guess. So this is 4 now. This one is now so 4. That one's still not balanced. Also, if you have odd numbers mostly on one side, then you'll usually solve for the odd numbers first. So put a 2 here because usually it's easier to start with 2 with the coefficient. So now this is 2, this is 2, this is also 2, and there's a 2 up there. So 2. Now this is 4. Equals 4. Okay, now these 2 are balanced. Oh, this one's not balanced over here. Okay, so now we have to find out how to make these guys balanced. Okay, so since there's a 2 here, I think let's just try 2. So 2 times 1 is 2, and now this guy is balanced. Okay. Yay! Okay, so our next reaction is double replacement. So this one is compound plus compound, and it's a different compound plus a different compound. Or, yeah, sorry. So we have AB plus CD, and that changes into AC plus BD. Okay, let's do another practice problem. So do the same thing that we did before. So iron is 1, sulfur is 1, hydrogen, 1 chlorine. Over here is 1 iron atom and 2 chlorine atoms. Right here you can't see, but it's H2. So, and sulfur is 1. Okay. So let's look at what we have. So these guys match. This does not match. Also the H does match. Okay, the hydrogen does match. So we have to balance this. So let's try putting a 2 up here again, because mostly it would be easier to start with 2. So this would cross out to be 2. This will be 2, and then these guys. So we have our chlorines are okay. This is all balanced now, because yeah. Okay, balanced. Okay, so our last one is combustion reactions, and this one always involves like molecular oxygen O2. When you burn anything, it's usually a combustion. So let's do another practice one. So do the same thing that we've been doing. My arm keeps getting stuck to the paper, the tape. So H4, 2 oxygen atoms, and then we have 1 carbon, 2 oxygen. The struggles are real. Okay, H2, that's not easy, that's a 2, there we go. Ooh, okay. Then we have 1 oxygen here. Okay, so let's see what we have. So we have 1 carbon right here, 1 carbon right there. Those are okay. So we need to balance this. Definitely need to balance this. Okay, so let's try putting 2 right here. So that'll be crossed out to be 4 because times 2 is 4. And then let's see, let's put 2 here. Then we're gonna do, so this is now a 4, if you can't see. And then this is now a 2. There. Okay, so 2 plus 2 is 4, and looks like it's balanced. Yay! Okay. Thank you guys so much for watching my video. Please like or subscribe down below. See you next time. Bye!